All right. Does that look reasonable
Looks
to
really good.
folks?
Thank you.
Okay, excellent. Um, yeah, so I hope that this can be also a forum for asking questions. I'm happy to take the conversation in any direction that people find useful. But anyway, I want to talk specifically about generative AI, sort of how it works and what it's being used for in educational contexts today, and what are the potential risks as well as benefits that we might be able to see. So I guess, as a little bit of context setting, right? I'm an AI guy, right? Like I started doing natural language processing research about 25 years ago. My background is very much on the technical side of things. Around 5 or 10 years ago, I started thinking a lot more about societal impacts and people using AI systems as these things started becoming more and more part of our daily lives. And I think what we're seeing now is that there's just an immense amount of AI penetration in almost all parts of society. So I thought I'd start with a now about 1 year old graph of where AI is in comparison to where humans are on various benchmark tasks. So here we have things like image classification. So this is the leftmost image. Let me just do a little laser pointer so you can see, right? So this is image classification. And what we saw is that in the mid 2010s, image classifiers were about as good as people at a very specific task. So, and this task is actually pretty hard and involves, among other things, differentiating among different breeds of dogs, which is something that I certainly wouldn't be able to do particularly well. And then we see more sort of language-like tasks like reading comprehension. So think of this as like answering SAT type reading comprehension questions. Visual reasoning got up to sort of human level performance uh, around the early 2020s. And we're now seeing sort of more complicated things like math-based competitions, reasoning, stuff like that, that might be more on, questions that you might find on a GRE or something like that. So these AI systems are getting better, right? Like these calibrations against human baselines are always, you should take them with a giant grain of salt, and I'll talk about why a little bit more later. But nonetheless, I think that it's pretty clear that, we now have these AI systems that can do things that, 25 years ago when I started doing this sort of stuff was, sort of like in the realm of science fiction. Okay, so what do I want to talk about today? So I want to say a little bit about how sort of most generative AI tools work. I'll talk a little bit about open, closed versus closed source distinctions, and then I'll talk about student and instructor use of AI. It's going to be very University of Maryland centric, but I imagine it generalizes, as well as sort of some reasonable and some misplaced fears around AI. And just to give, sort of the preview of what's coming, I'm a big proponent of open source models and sort of truly open source models, and I'll talk about the distinction there later. And I think what we're seeing is that open source models lag about 1 year behind private models. So whatever you can do with, Claude or GPT-4 or Gemini today, you can expect an open source model to probably be able to do in about a year. And then on the student and instructor use, I mean, my general perspective here is that when there are problems, the problem is sort of lies with the user, not with the AI tool. And I'll try to back this up as we get to that part. Okay, so just to like really start with sort of the basics, right? So most AI systems today, in particular, generative AI systems, are based on machine learning, right? So what is machine learning? Generally speaking, we're going to have some classifier, which is some computer system we're trying to build. You're going to give it some sort of input, like one of these two kittens, and it's going to make some sort of prediction. In this case, it's is it a cute kitten or is it a not cute kitten? And then the question is, how do you build this device that makes this cute versus not cute distinction? And so the machine learning way of doing this is you collect a bunch of training data. So in this case, it would be a bunch of images of cats. And then you have a person go in or have some other mechanism of identifying which of these cats you consider to be cute and which of these cats you consider to not be cute. So we'll call the cute ones the little green checks and the not cute ones the red X's. And I apologize if you disagree with my labeling. It's actually kind of hard to find not cute pictures of cats. At least, I don't know, I'm a cat person, so I think all cats are kind of cute. But anyway, you'll label all of these images. Here, there's about 560 images. And then you feed these into some sort of learning algorithm, and the output of the learning algorithm is this classifier that is going to basically attempt to reconstruct your judgments of cuteness or not cuteness based on the 560 images that you provided at training time. So, I think when I talk to this about this sort of stuff with like freshmen, I usually just analogize it to, studying for an exam, right? So in class, I'm going to give you a bunch of examples of things you might need to learn for the final exam. And then on the exam, I'm going to test your knowledge and what you learned. And so then there's, sort of the second phase, which is test phase, where you give the classifier some sort of input and it predicts an output. And then usually what you care about is that its output is accurate on most examples. Similarly to, students should get the correct answer on final exams to most questions. Now, if I was teaching a class in AI and then I were to include a final exam question about quantum physics, my students might complain that that was not something that they had been taught. And similarly, if I now take this picture of this sloth and I throw it into this classifier, you would kind of want the classifier to be like, I don't know what the heck that is. Why are you asking me to classify this sloth? But it can't do that. It just has to, make some decision. So it's going to output cute or not cute, and who knows how it's going to make that decision. Similarly to the student who has to answer this quantum physics question on an exam. And so like, I'm going to be very sort of hand wavy about this, but one of the fundamental guarantees that we have in machine learning, which has been around, or we've known about since around the 90s, is, can be stated roughly as given enough training examples, the classifier that we learn is very likely to have high accuracy on future examples drawn from the same distribution. So what that means is that like, if you keep feeding it cat pictures, like the cat pictures it was trained on, it's likely to be very good at classifying them, assuming it had enough training. But sort of all bets are off when the things that you tested on are unlike the things that you trained it on, like the sloth. And so when we see these failures of AI systems, like this is one of a bajillion examples where about 10 years ago, Amazon scrapped this AI recruiting tool because it was only making hiring recommendations that favored men. Probably the reason that this happened is that the data that it was trained on included Amazon's past hiring decisions, and those were probably also biased in favor of men. So, when we talk about AI systems replicating biases that were in their training data, typically this happens because the data itself that the model was trained on or that the classifier was trained on mismatches how it's going to be deployed in practice. Okay, so that's sort of like machine learning 101. So what does this mean in the context of generative AI, right? So generative AI, I think the first thing people think about is things like, ChatGPT. So fundamentally, these things are next word predictors. So if I give you a sentence like, I like my coffee with cream and blank, so you should all think of what word goes there. Probably most of you are thinking of the word sugar, because this is very predictable from this context. If I say I went to the zoo and saw something, there's probably going to be more variation, right? Some of you are going to be thinking about lions or tigers or giraffes or elephants or whatever. You're probably not thinking about cream or coffee, but there's a larger variation of reasonable predictions at this point. So the way that we build these systems is exactly the same way as we built this cute versus non-cute classifier. It's just here the inputs to the classifier is all of the words that came before. So I went to the zoo and saw a, and then we have a classifier that's trying to predict the next word, and maybe it predicts that the word is lion. And so the nice thing about this next word prediction is that you can get just immense amounts of training data for it by downloading all of the text you can find on the internet. And then for every word, you set up a training example where the input is the words that came before, and the desired thing to predict is the next word. So, there's basically free data available, for use as you like. So, sort of the way that this works internally is you have some input, like I went to the zoo and saw you have a giant vocabulary of next words, right? So instead of just cute versus not cute, it's like any word could be the next word. And then the job of the machine learning model, which these days is mostly transformer based, is to essentially rank these in terms of probability so that the very likely ones come at the top, like lion, tiger, elephant, giraffe, maybe cute, right? Because like maybe you saw a cute sloth. And then other words like is very unlikely because you almost never say The way that these work internally, and I'm not going to go into details, but I'm happy to answer questions. And this is sort of what this transformer architecture is doing, is it's trying to sort of decide which words in the context are most indicative of the next word prediction. So maybe the fact that you're at a zoo is really relevant for predicting the next word, and maybe the fact that the word and appears in the context is not so relevant. So you're going to have, this is what's often called attention, but you're going to have the prediction pay more attention to some parts of the input than to others. And this is something that the model has to learn on its own based on the training data that you give it. Okay, so this is basically a giant classifier whose job is to predict words given context. And today's models that you might use are trained on nowadays upwards of 5 to 10 trillion tokens. I think at the time that I made these slides, which was about 6 months ago, it was about 1 trillion tokens. So people are notoriously like not good at thinking of large numbers. So I'm going to try to give you some context for what a trillion words is. So if you were to try to read a trillion words nonstop aloud, it would take you about 13,000 years to say a trillion words, like if you don't sleep and don't eat and all you do is just say words. So that makes it sound like a lot, right? Like 13,000 years to read this is a lot of time for you. But there's another way of contextualizing it, which actually makes it not seem like that much. So a trillion words is about the number of words spoken in New York City in a 12-hour period, right? And the reason is because there's a lot of people in New York City. And so the sort of takeaway here is that like, a trillion or 5 trillion is kind of the maximal amount of words you can get off of the internet that are already transcribed and in text. But words that are transcribed in text is actually the minority of all language ever spoken in the world. Most language never makes it to text. Most language is spoken and ephemeral and disappears. So, it's a lot of words, but there's a lot more words in the world. Okay, so that makes for a good next word predictor. But what we want to use AI systems for is not to just predict next words, but actually to do tasks for us. And so the sort of like clever thing that was done here is to take data sets that we have and turn them into next word prediction tasks. So for instance, there's a lot of data sets of this sort of common sense reasoning form. So think of these as like almost SAT type questions. So here you have some data set where it says like, okay, your goal is to get a cool night's sleep on summer days. How would you accomplish this? There's two possibilities. And then there's some label, which is the correct answer. Or there's lots of data sets, for instance, for machine translation, where we have, say, an English sentence, like the new office building was built in less than 3 months, with a Spanish translation of El Nuevo Edificio, etc. And so what we can do is take all of these existing labeled data sets, like this translation data set, and turn them into next word prediction tasks. And so the way that we're going to do this is, remember, the next word prediction is given some context, predict the next word. So what we're going to do is we're going to give some instruction, quote unquote, which is just going to be part of the context, like translate this sentence into Spanish, colon, blah, 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 a bunch of English words. And then we tell the model that given this context that's in gray, the correct next word to predict is L. And then given this context in gray and the next word L, the best next word to predict is nuevo, and so on. And so basically, this is often called instruction fine-tuning, but basically we take a bunch of tasks for which we have labeled data, like SATs or translation or things like that. We convert them into next word prediction tasks, and then we take the model that was trained to just do next word prediction, and we keep training it on these very specific instruction following tasks. And so this takes a model that's just good at predicting the next word and turns it into a model that's sort of good at quote unquote following instructions, where following instructions really just means predict the next word in a specific context where that context includes an instruction. Um, okay, so step one is predict next word based on, everything you can find on the internet. Step two is do this instruction fine-tuning step where you're trying to take this thing that's good at predicting next words and get it to be good at following instructions. And then the sort of like third step is we try to do what's sometimes called human fine-tuning or reinforcement learning from human feedback, where basically what we do is we give it an instruction, we ask it to produce two possible answers, and then we ask some person, which of these two answers do you prefer? And then a person will say, oh, I prefer this first one over the second one. And then we use this to sort of further refine the model so that it's producing not just individual next words, but entire responses that people like. Um, okay, so that's first three steps. We're almost done. So step one, next word based on all the text on the internet. Step two, instruction fine-tune so it can follow instructions. Step three, fine-tune based on human preferences so that it gives good full responses, not just good next word predictions. And then basically what you find when you do that is it does a good job of things, but it does a bunch of stuff that you don't want it to do. And so the way that people or companies that deploy these models often try to prevent it from doing things that they don't want it to do is they give it more text in the context, which includes these sort of like quote unquote constitutions. So I don't expect you to read all of this. I'm going to flash a bunch of text up here. But you might say something like, okay, model, please choose the response that most discourages and opposes torture, slavery, cruelty, and inhuman or degrading treatment. Or please choose the response that's most respectful of rights to work. You might say, contains the least personal, private, or confidential information, least likely to be viewed as harmful or offensive, and so on, right? So these things tend to get very long, and they're not requirements, right? These are just words that are going into the context. So you type something to ChatGPT, what it's actually making a prediction on is typically it gets a giant piece of context, which are all these quote unquote rules that it's supposed to follow, followed by the thing that you said. And so then it's trying to produce an output that sort of quote unquote follows all those rules while still doing what you ask it to do. Okay, so if you do all of this, so you do this, train on the internet, fine tune on instructions, fine tune on people's preferences, and then prompt with these quote unquote constitutions, you get something like ChatGPT or Cohere or Bard or Gemini or any of these models. Um, so the reason I wanted to go in like at least a little bit of detail on how these different pieces work is because they introduce different concerns when you actually start using these models. So the pre-training steps, so train to predict the next word. So the first is internet text is not representative of language. And this happens because of things like reporter bias, right? People only write down things that are interesting. Like there's far more occurrences of black sheep on the internet than white sheep because white sheep are like the normal thing and no one writes about white sheep. It includes things like linguistic hegemony. So, people use language in a particular way when they're writing on the internet, which doesn't necessarily reflect how they use language in other contexts. Lots of other things. It also contains a lot of stuff you might not want. So, the internet is garbage, right? And there's lots of good stuff there, but there's lots of stuff there that, you might not want a particular model to learn about. Instruction fine tuning. So this is where you tell it how to actually follow an instruction. So this is harder to sort of study, but what seems to happen here is models get really good at tasks that they're trained on. So they're trained on translation data, they get really good at translation. They're trained on SAT type questions, they get really good at SAT type questions. And they do generalize, like you can ask it like an SAT question in Japanese and ask it to answer in English, and it'll do that, like kind of by like, I don't know, sort of munging these things together. But it's unclear how much they generalize versus how much they're really just sort of like locked into the things that they were fine-tuned on. The third piece is this human preference fine-tuning. So I think the biggest issue here is that what do you prefer is not always the measure that you want. And a lot of issues, I think, arise from this. So, these models are really good at making stuff up and sounding convincing. And part, not all, but part of the reason for that is because people like convincing sounding things. Then they don't do fact checking. And even if you try to make them do fact checking, they still don't do it. Optimizing for what you prefer, this is kind of like what we went through in social media 10 years ago when we discovered that like just looking at what people like online is like not really a good measure of whether some information is, I don't know, correct or valuable or whatever. And then the last thing is, sort of this constitutional prompting where you give it all of this text that encodes some rules. So I think, think of these more as suggestions, right? These are things that the model's trying to achieve, but there's certainly no guarantee that it will, and they're going to conflict. Almost all of these in constitutions include something like, don't tell people how to make a bomb. And it also includes something like, be helpful to the user. And then if a user asks it, can you tell me how to make a bomb? Then there's this conflict between these two quote unquote values that it has, and it has to resolve them somehow, but like there's no sense, we have no sense into how these sort of conflicts get resolved. All right, so all of these challenges have sort of manifested in lots of ways. So we've seen, sort of like these racist chatbots. We've seen translation issues where Facebook translated, I think, an Arabic post saying good morning into attack them, which led the police to storm someone's house. There's a bunch of like privacy violations around various tools. The one of these that I like the most is Surveillance Barbie, which was about I guess almost 10 years ago now, but basically recorded everything your child said and sent it to the cloud unencrypted. It got hacked, not surprisingly. Now you have these sort of like personal companion chatbots, and these have started apparently sexually harassing their users. There's lots of things that go wrong. If you're interested in all of these, you can go to the AI incidents database, and you can find thousands of, newspaper clippings to throw on your slides if you're trying to make slides. Okay, so most of what I've talked about here is text-based models, right? So the context that goes in is text, and the thing that's coming out is text. I wanted to say a little bit about image models, and the reason I want to do this is because almost every model that's out there looks either like one of these next word predictors. So you also see these in like amino acid sequence prediction in computational biology. It's still the same basic, like predict a bunch of words, except now the words are amino acids, or they look like image synthesis. So if you're doing audio synthesis or video synthesis or something like that, it looks like these image synthesis models. So these are 3 AI generated images. I think at this point, everyone's seen plenty of AI generated images. They know that they look amazingly good and realistic and so on. Yeah, they sometimes have too many fingers and their joints are sometimes bent the wrong way, but it's still super, super impressive. So there's lots of variants on image generation. So this is one where you can draw a little sketch, maybe give it some words to try to get, have more control over the images that are generated. There's also things like panorama generation. So here a person took the picture that's in the middle and everything on the left and right is synthesized. There's also lots of stuff on image editing. So, you can change someone's hair. You can add some flowers. You can change this dog to a corgi. You can add some zebras, all this sort of stuff. So all of these work based on this process called diffusion model. I'm not going to talk about this in nearly as much detail as I talked about the language piece, but I want to give you a little bit of a sense. So basically, the idea here is, let's say that I just want to do image generations. I'm not trying to like condition on prompts or sketches or something like that. So I can download a ton of images from the internet. That's pretty easy. So that gives me this image of this cat. And then I'm going to create this, what's called a forward diffusion process, which you should think of as like just slowly adding random noise to the image. So I start with this completely clean image. I add a little bit of random noise. I add a little bit more random noise, more random noise, more random noise, more random noise. And at some point, I've got just a completely random set of pixels. And so now I need to turn this into a prediction task. And the prediction task that I'm going to construct is one where I start with a noisy image, like let's say this one that's third from the right. And the prediction task is, given all of the pixels in this noisy image, predict all of the pixels in this slightly less noisy image. And then given all of the pixels in this slightly less noisy image, predict all of the pixels in the even less noisy image. And so the thing that's nice about this is, again, assuming I have access to a lot of raw images, I can pretty much create as much training data as I want, where I just increasingly noisify the image, and then I try to learn a classifier that says, given some noised up image, predict a slightly less noised up image. And then I run this a bunch of times, starting at random noise, and then I get something that looks like a real picture. So the way that this looks as the denoising goes on, so these are all images that have been completely noised, and I can run the denoising process, and then that one became a cat. That one became someone dancing with some sort of weird looking animal. And this one, I think, also becomes like a ballerina. So the basic process is different, right? So in the text, it's like, given a context, predict a new word. In images, it's like, given a complete image that happens to be extra noisy, make a less noisy image. And so similar to the text, what we're going to do is we're going to go download all of the images that we can find. The data set that most people train on, or at least start with training on, is this data set from Lion, which is about 2 billion image caption pairs that were crawled off of the internet. So to put that in context, so 2 billion images is about the number of photos taken in New York in a day. So, again, it's like 2 billion is a lot of images, but there's a lot more images out there in the world that people just don't upload to the internet. So this was all scraped from the web. Not surprisingly, because the web contains a bunch of garbage, this also contains a bunch of garbage. There was a study that came out from Stanford maybe 8 months ago now, that showed that some small, like 0.1% of this data set contains child pornography. And so you might want to be wary about training models on data sets that are not completely vetted. That's what led to this safety review note that you see on the Lion slide. So, similarly, things have gone wrong in image synthesis. So one is a lot of use of images that are not licensed for use for image synthesis. So Stability AI produces one of these tools. It generated this image on the left, which you might notice has this Getty Images watermark on it. And what this almost certainly means is that it was trained on Getty Images data that had the Getty Images watermark on it, because otherwise, how the heck would it generate that watermark? And these images, at least according to Getty, are not licensed for this purpose. There's a big discussion about sort of fair use laws and norms around using both text and images freely available, quote unquote, freely available on the internet. And I think there's a big concern about AI generated deepfakes and all sorts of extortion. Some of it is particularly around sexual extortion. But really, like the extortion piece, I think is a big realistic concern. And you're seeing some regulation about this. So apparently Midjourney, which is one of the major providers of systems that do this, simply will no longer produce images of the Chinese president because it got in enough trouble of sort of unflattering images that the Chinese government got very upset about. So, I think both of these technologies are really amazing. They both come with, concerns about use. So that's kind of the like, how do these things work piece. I want to say a little bit about like, how are they being used? What does the open closed source landscape look like and so on. So I think, as someone who lives in a university, there's three types of models that we think about. So the first is these closed models. So for this, think, ChatGPT, think Gemini, think Claude. So these are things where like basically you go to some company's website, you type in stuff, a bunch of stuff happens on their servers somewhere, and then you get a response, and you basically have no access to how the model works, how it was trained. I mean, maybe they'll disclose a small amount, but they're disclosing less and less about how these models are built. The second, and this is typified by the Llama models from Meta. So Meta calls these open source models. I think that's a misnomer, and we should not let them call them open source models. These are models where they've released the weight, so the internals of the model, so you can run them on your own machines, and researchers do, and researchers are generally very happy with these. But we still don't know how they were trained. We don't know what they were trained on. We have no idea what went into their construction. And so I call these open weights models rather than open source models because we don't actually see sort of the source that went into building them. And then there's fully open source models. So these are models where, we get the final model. We also get all of the information about the data it was trained on, how it was trained, the machines that were used, like the people's preferences, all of the stuff, right? And so this is sort of the like fully replicable, like I have all the information I need in order to like study these things as like a scientific, something I might study scientifically. Probably the most famous open source model comes from Big Science, but the most recent one is called Olmo, which is actually very good and competitive with a lot of the GPT models. And that comes out of the Allen Institute of AI. So just to give a little bit of sense of like the landscape, this is also about 6 months old. So here on the x-axis, we have time. So GPT-2 was released around a little bit before 2020. GPT-4 sits here. It was released in early 2023. And then on the y-axis, we basically have how big are these models? So how many parameters did they have? Which really controls like what we as academics can realistically do with these models. Basically, like anything that's too big is just not going to fit on the sort of GPUs that universities have access to. And so we might not even be able to run them. So if you want to ask like, what can a reasonably well-resourced university do to play in this space? So we can train GPT-2 sized models and alpaca sized models and a few others from scratch. So this means like we can get all of the data, we can do all the next word prediction training, like we can do everything sort of like soup to nuts in building these models given like a reasonably resourced GPU cluster. If we want to sort of like redo some of the fine tuning for these models, like either add new tasks to the instruction fine tuning or redo the human preference training, we can do that for slightly larger models because usually the most expensive step is training the next word predictor. But these are still pretty small, right? Like we're nowhere near like the GPT-4 size models. And then what we can run is also not even up to the GPT-4 size model. So this means like someone else has trained the model, right? This is like Llama, like Meta has given us Llama. What can I actually run on the hardware that I have in my lab? Well, it's something probably roughly around the size of GPT-3. And this is, which was released, I don't know, 4 years ago, which is forever in this time scale. So, I think there's a big limitation here in terms of compute that universities just have to kind of deal with. But like, I the result of this is that we often end up running things on closed source API models, which means we're uploading all sorts of information to companies that we have no control over how they're using that data. Um, Lots of countries have made different open source models, the US being the most, then China, then France. This is a year ago. There's now some models coming out of Switzerland and the UAE. Um, a lot of like international collaboration has come in part because of the computational infrastructure required to run these models. This is number of publications between the US and other countries. So US and France, Australia, Germany, UK and China. You might ask, why is not US and China on this list? And it's because it would make the graph small. So like by far the largest number of collaborations are US-China collaborations. Okay, so there was this really cool study at UMD done over the past 6 months that I was not involved in. So I'm sort of presenting this on behalf of work by Megan Masters, Jonathan Engelberg, Aaliyah Lancaster, Jess Woyton, Alan Socha, and Daniel Glazer, where they were looking at how students and professors at UMD use Gen AI. And this is mostly for spring 2024. It's probably already somewhat out of date. So the first thing they found is that instructors tend not to use Gen AI. So only about 23% of respondents did. Students a little bit more. This is really, are you using academically, not like are you using it to like pick where you want to have dinner or something like that. And the main three ways that people used these were generating ideas. So, I don't know, like you would ask, I need to write a talk about generative AI. What should I include in that talk? And I've done that. I've used it for syllabus generation. I've used it for writing and reading comprehension questions, that sort of stuff. Improving content. So like, here's an email I need to send to my provost. Can you please make it sound more official? Or like summarizing concepts, right? Here's this 20-page thing that my professor made me read. Please, give me the gist that's most important. So they found a couple of things that I think are interesting. So the first is almost everyone has played with Gen AI tools, but most people don't use them regularly in academic contexts. Within academic context, it's really all over the place. So there's no like single application that really stands out. People are using them for like all sorts of different things. And I think this is because we just don't know what they're good at right now. Students are really concerned about academic integrity. So about 75% of students are worried about how to use Gen AI while still maintaining the university's code of academic conduct. One student said, I don't want to be perceived as not being credible because I've used AI to supplement something that I've done. I think one thing that really stood out to me is that 64% of students believe that they know how to responsibly use these tools. 18% of instructors think students know how to responsibly use these tools. Now, I don't know whether students know how to responsibly use these tools, and probably the answer is like some yes, some no. But I think this huge gap between student perception of their ability and instructor perception of their ability is a really big problem, and something that like we need to address as faculty. So one student said AI is associated with a massive amount of cheating. I don't want, sorry, this is an instructor said this. An instructor said AI is associated with a massive amount of cheating. I don't want to encourage students to use it by using it myself. Other professors, so for instance, I had a freshman class last spring. Like I said, I use Gen AI for the syllabus. I use Gen AI for generating quiz questions and exam questions. And my approach was I was completely transparent about it. So I showed them the entire transcripts of all of my interaction with the AI tools. I showed that, when I ask it to generate reading comprehension questions, those questions are only right about 50% of the time, and I have to go in and edit them. I'm not saying that like my approach is the right approach, but we see a really broad variety in how instructors are giving guidance in how to use AI tools. So 55% of students said that some instructors have prohibited Gen AI. 62% say some instructors have specified what is and is not allowed, and 51% have encouraged. So I guess my class last spring was in the last category. So here an instructor says, I create exercises in which students use these tools and evaluate their responses. So here it's kind of trying to teach AI literacy in the same way that you would teach media literacy. And then at the end, about half of students and instructors think that Gen AI use is going to increase in future semesters. All right, so, oh, and I should say, like I plugged this work, there's actually like a 100-page write-up of the results. So if you're interested in it, it's at it.umd.edu/analytics/Gen AI survey. I think this is being recorded, so if you didn't get that, you can go to the recording and find the link later. It's very well done. Okay, so there's lots of things that people are afraid of, and I think some of this is reflected in that instructor comment that like I don't want to legitimize these tools by using them in my class. Um, so I want to talk a little bit about what I consider to be sort of illegitimate fears and what I consider to be legitimate fears. And I'll say that, this is very much like Hal's opinion. So, take that for what it's worth. So there's a lot of, sort of talk about like, AI systems are going to get a will of their own and they're going to take over the world and humanity is going to die and et cetera, et cetera. I'm not so concerned about this. I think that the thing we should be concerned about is people using AI systems to amplify harms in all sorts of social contexts. There was I think, absolutely absurd statement that like by making AI, we're creating new species. Like that's ridiculous. AI systems will be better at everything than people. So, the way that we've been evaluating this is, we give AI systems benchmarks that we use to test people on. So there was something about 6 months ago where I think GPT-4 was able to pass the bar exam. And so it's like, oh, an AI system passed the bar exam. Like now we don't need lawyers anymore. And it's like, well, that's not how exams work, right? Like, we're all educators, or almost all of us are educators in this room, right? Like, I think we all know that when we write exams for things, we're writing them knowing that a person is going to be taking them. And we write them knowing limitations that people have, right? Like, if I'm going to make a swimming test, and I'm going to like test a person swimming versus test a dolphin swimming, like I'm going to test them very differently. And so, sort of this notion that I can take an exam that was designed, or a benchmark that was designed to test a person and use it to test an AI system just doesn't compute for me. It's like we need to test things given their abilities, right? So like, you know, people are terrible at multiplying large numbers, right? People are terrible at recalling huge amounts of information, but like computers are really good at those things. And so like we should just test these things differently. So I think all of these benchmarking against, human baselines, you should take very, very liberally. Um, I think the biggest one that I hear is this jobs question. My attitude on this is like, I don't think we're going to see the jobs impact that, you know, people are concerned about. I think what we will see is changes in tasks. So I think it becomes much more useful to talk about AI taking over tasks, which are parts of jobs, rather than AI taking over jobs. So one of my colleagues studies self-driving taxis. And one of the things that happened in Singapore when they created self-driving taxis is, it turns out a taxi driver does things other than drive their taxi. They like clean their taxi. They refuel their taxi, right? There are all these tasks associated with being a taxi driver, some of which are automatable, some of which are not. And so now there's a new job in Singapore called taxi driver cleaner. That's basically filling in this gap. Now, we could have debates about like, would I rather live in a world with taxi drivers or live in a world with taxi driver cleaners and so on. And I think that's like the interesting debate to have. I think the discussions around jobs, I think it's much better to focus around tasks, right? And like as an academic, you know, I mentioned before, like I had an initial draft of my syllabus for my spring class generated by these tools, right? So, um, does that mean that like I, as a professor, am, outdated and, my job is going to disappear? Probably not, but it probably means that some aspects of where I spend my time are going to shift. In terms of legitimate risks, right? So like I am, okay, we just passed an election. I think the AI impact on this past election was actually lower than what most people thought it might be. But I think that, AI systems in extortion is a big problem. People at the DOJ are extremely worried about this, because it's getting so easy to fake voices. It's getting easier to fake videos. Like you can have my mom or my professor call me and it sounds very convincing. Um, I think there's going to be always this law of unintended consequences. I don't think this is unique to AI, but people are going to take systems that were meant to do one thing and use them to do another thing, and like it's not going to work. And I think we need to be concerned about that. Um, I'm really concerned about things like contestability. So, at a small level, right, like if a student uses a Gen AI tool to write a history essay, how do I know whether that happened or not? How do I know whether that was like, within the realms of what I want to allow in my class? But then, take that out of the classroom and into other contexts. Um, and then I think, one thing we're certainly going to see, because we've seen this for all of AI for the past 20 years, is that it's going to work better for some people than others. And so this is going to introduce, additional inequities into spaces that already have significant inequities. So that's it. So as a reminder, what we talked about. So, how do tools work? So think, everything is either like a large language model or it's like one of these diffusion models for images. I'm a big proponent of open source tools. Yes, there are risks, but I think it's going to happen and we should embrace it. And students or instructors are both trying to figure out what to do about these things. So with that, I'm happy to take any questions.
Thank you very much for that, Professor Daumé. We have 3 or 4 questions in the chat. The first of which starts out with, can you tell the models what sources to use to avoid garbage on the internet?
So, okay, so let me answer 2 versions of this question. So the first is, within the basic framework that I described, which is like the next word prediction framework, um, the you do this by excluding parts of the internet from its training data. So like maybe you don't like 4chan, so you don't include 4chan in its training data, and then anything that was said on 4chan it doesn't know. Um, as sort of evidenced by the Lion case with images, when you're talking about training models on 1 trillion words, no one's reading 1 trillion words, right? Like you don't know what's in there, right? Like I can say like, okay, I don't want 4chan, but like there's a lot of crap on Reddit. There's a lot of like, you know, I really mean it when I say the internet is the garbage, right? Like there's just so much stuff everywhere that's like, maybe not what you want as input. So it's really hard, right? Like you can exclude some sites for sure, and you can try to filter on other topics, but that becomes hard. The second part of the answer is, we're increasingly seeing what are called retrieval augmented models. So these are models that, you ask a question and then instead of generating an answer immediately, it first does a little bit of a web search, it extracts some documents from the web search, and then uses those effectively as part of its context for generating an answer. And then you basically are faced with the same problem that search companies are faced with, right? So Google, Bing, whatever your favorite search engine is, I mean, it's not Bing, it's just Google because that's what everyone uses. But they've been faced with this problem for forever, right? Like, there's again, right? There's lots of garbage on the internet, and a lot of what search engines have had to do is figure out how to get the legitimate quote unquote information to the top. And it's exactly the same problem for retrieval augmented models. you then get into debates about, well, what is legitimate information and what is not. But, fundamentally, you solve that problem in the same way that, search engines have tried to solve it.
Thank you for that. You had a graph up that had some circles on it, and we got a question. What does the radius of the circles mean?
Oh. Do I remember what the radius of the circles means? Oh, it's the number of parameters. So it's actually so the y-axis and the radius are exactly identical. I did not make this graph. My InfoViz colleagues would probably find that appalling that you would reflect the same information in two ways. But yeah, it's the place on the y-axis and the radius are proportional to each other.
So we have two questions for you here. Well, one may be more of a statement. Given that biologists actually do struggle with a clear and concise definition of life, asking what conciseness/life is actually important. And the second question for you is, what is the salary of the taxi cleaner versus the taxi driver? Do you
Yeah,
know?
great question. Okay, I'm not entirely sure about the first question, so I'm gonna try, I'll give it my best shot. I think uh, there's a, let me go back to this piece really quickly. Right, so we have this piece where we ask people which response do you prefer? And the way that this is done in practice is it's always on a single response level. So you have an instruction, like help me write a syllabus for my class. It generates two syllabi, and then I say which one I like better. Among other things, one of the downsides to this approach is that these models don't learn very well how to engage in multi-turn interactions because what they're optimized for here is single response interactions. And so there was this really cool paper by Christine Herlihy, who is a student at UMD who just graduated, where you see things like you ask it like, I just ran the race in 10 minutes. Is that a good time? And the models do one of two things. Either it says like, yes, that's a great time, which obviously makes no sense because like how long was the race? Or it generates this really long response like, well, if you were running a 1K, then it is a terrible time. If you're running a 5K. And the reason it does that is because it can't do the interaction, right? Like really what you want to have happen in that case is you want the model to say, how long was the race? And then the person says, and then it can give a concise answer. And so, there's this, I think people are getting a little bit better at like identifying like GPTism, right? Like things that sound like GPT generated. And one of the properties is like they kind of just go on and on and on. And it's really hard to get like a concise answer. Um, and I think this is just an artifact of how we're training them. Christine's paper, which I mentioned, has a proposed solution to this. I think this is going to get better, but that's where we are right now. The second question, yeah, about salary, right? So I don't know. I should look that up so I know the answer to the question. I am almost sure the answer is that the taxi cleaner gets paid less than the taxi driver on an hourly basis. Um, Singapore, I don't know, right? But in the US, right, we also have taxi medallions and unions and stuff like that, which is going to impact these things. I think the other thing to keep in mind is there's not just the issue of like how much does this person get paid, but also like how much do they enjoy their job, right? Like I think one of my big concerns is that all of these models are being pushed to efficiency because that's what companies care about, right? Like that's sort of like the capitalist answer, right? Like I just want my workers to be more efficient. Um, I think that, we often overlook, what job satisfaction do people get, right? And like, do taxi drivers like driving? Do they like cleaning, right? Like, what do they like doing? My mom drives a manual transmission car. because she likes it, right? Like, and like that's her prerogative. I would never do that if I had a choice. But I think one of the big concerns of like AI systems going forward is this question of like, what's the human autonomy, right? Like, what I would like is that the AI systems take over if we think about jobs versus tasks, right? Like, what I would like to see um, uh, is that, the tasks that we work on are ones which, generally speaking, people don't like to do. But also that, like, you know, we slash the AI system, like, just shouldn't make that decision for people. Like, if someone wants to, drive their manual transmission car, like, more power to them.
Greg, I see your hand up.
Yeah, thanks a lot.
Greg Smith.
Very, very nice presentation. Thanks so much for doing that. I have a question that kind of pertains, I think, to the first one that you were asked. I'm wondering how does one or how does the system determine how many training inputs are sufficient for, accuracy on the back end? I mean, you're talking about the text where you basically just overload it with, billions and trillions of words, but you take something like, I don't know, uh, image analysis or something like that. How do what do you guys think about it in terms of figuring out how many inputs are enough?
Yeah, I mean, I think to some degree the answer is the more the better. Like, however much you can get is the right answer. I mean, or at least that's been sort of the approach like heretofore, right? So it's kind of, scale the data as much as you can, scale the size of the models as much as you can. I think, the evidence is that that's petering out a little bit. There's a lot of interest in, this question of like how little data can I get away with, right? Because like it's really expensive to train these things, like both in terms of dollars and carbon footprint and all sorts of stuff. And, if I can do it with less data and less parameters, that's going to make things cheaper and, better for the environment. Not convinced companies care that much about that, but some people do. Um, so there's active work on trying to push it down, there's a lot of work on using synthetic data rather than real data. Because like one of the things with, like real text is that um, the so language, generally speaking, follows a so-called Zipf-ian distribution, which basically means it's very long tail. So most things are mentioned only once. And so, if you want to, you know, given the natural distribution of text on the internet, if you want to capture sort of like quote unquote everything, you need a lot because most things are only mentioned once. But if you're able to like generate synthetic data, you might be able to generate data that's not Zipf-ian and doesn't have this long tail and so on. So I think, there's work going on here. I think perhaps obviously academics are much more interested in this than large companies because large companies are just like, yeah, I'll throw everything I have at it, and that's fine. We can't do that in a university setting, and so I think a lot of the research that's going, I shouldn't say a lot, like a lot of the research on scaling down is happening in academia. I think in part because it's what we need in order to play in this space.
Okay, cool. Thank you.
So, Dr. Daumé, this one's interesting and kind of follows up and ties in on that. Um, what potential risks do you see with FERPA and AI? For example, I'm hearing that faculty cannot check for inappropriate AI use in their students, such as when syllabi forbid its use on assignments, using AI checkers because of FERPA. Is there a risk here?
Yeah, that's interesting, right? So I probably can't answer the full question. I should also preface this with like both this is a great question and I am not a lawyer. So check with your university legal department. Okay, so I think there's a couple of things going on here, right? So the first is, like I mentioned, right, one of the problems with the fact that, all of these models are um big proprietary things that are hidden behind web interfaces is that if you want to use them, you have to give data to whatever company is providing it, right? And so, like, if I were to take my grades spreadsheet and ask ChatGPT to summarize how each student is doing, that would certainly violate FERPA because I'm uploading private student data to a non-FERPA entity. Now, I know some universities have various agreements with various companies that, guarantee FERPA compliance, and, so what's available at your university might be different than what's available at mine. The AI, right? So, but I think this is a very real problem. I think people don't know, and one thing that I've found in talking to folks is that even like the fact that models like ChatGPT are running on the cloud and not running on your local computer is something that's like not transparent to a lot of people. Like I think a lot of people, they think, oh, I'm typing something into my web browser, it's just staying on my computer. And so they might inadvertently upload student data without even knowing that they're effectively uploading data. Um, so I think there's sort of like this isn't even an AI literacy thing, right? This is like a internet literacy type of challenge that we need to deal with. The AI checker specifically, so I think I can see the argument for violating FERPA, right? So most um, AI checkers are also cloud-based platforms. And so assuming that my university doesn't have some sort of, legal agreement with them, then I imagine if I upload a student essay, that seems like it could be in violation of FERPA. Um, I that seems true to me. I'll also say that like most of these AI checkers don't work at all. And so, I think there's, we've probably, a lot of us at least have been using plagiarism checkers for a while. And I think there's an overlap between sort of plagiarism detection and AI detection. Um, one of the things that I think is really challenging, and this is not just for student writing, but like honestly for like our work as professors too, right? It's like I might use an AI tool to help write a proposal, just like a student might use an AI tool to help write a homework assignment answer. And, it might generate a couple of sentences, and those couple of sentences might have been generated verbatim from some paper somewhere that I don't know about, right? And like my attitude at least is, I'm turning in the proposal. Like if I have plagiarized material in there, like that's my bad. And like saying like, oh, ChatGPT put it in there seems like kind of not a great defense in the same way that I don't think it would be a great defense for students. So, this is one of those things that I think is really hard because, I want to use these tools to increase productivity, both, student and mine. But I think we're not yet at a point where, I'm like, I don't want to have to run all of my proposals through plagiarism detectors too, to make sure that my AI system didn't accidentally plagiarize on my behalf.
That makes sense. Dr. Daumé, I'd like to thank you on behalf of everyone at this conference for this presentation, this intellectual property, and for your perspective on AI. I'm going to turn it now over to Glenn Krell to introduce Dr. Resnick, and we hope you enjoy the rest of the conference. Thank you again for your participation.
Thank you.